Everyone, and today I will be describing the graph of y is equal to e to the power of x over x for our END 1020 S course. As you can see on the graph, our domain tends from negative infinity to 0 as well as 0 to infinity. Our range, as can be seen, is from negative infinity to 0 or 0 to infinity. Our intercepts are calculated by equating x to 0 to solve for your y-intercept. As you can see, when we make x equals 0, there is none. There is no y-intercept, therefore x equals 0 is your asymptote. And for calculating your x-intercept, we equated y to 0, and there is no solution for x being an element of real numbers. In order to calculate for the symmetry of the graph, we subbed in negative x, and as you can be seen, this does not equate back to the original function. Therefore, the graph is neither even or odd. I will now hand over to Daniel Oko.
Yes, so now we carry on with the asymptotes. To get the asymptotes, the vertical asymptote, we solved for the limit as x approaches a from the negative side, and that gave us a value of fx equals positive or negative infinity. And then we solved for the limit as x approaches a from the positive side, and that also gave an answer of plus minus infinity, and therefore this means that the x equals 0, and that is our vertical asymptote. Our horizontal asymptote, we found that x approaches positive or negative infinity, which also means that y will equal 0. So these are the asymptotes of the graph, that x equals 0 and y equals 0. For our critical points, we just found the second derivative and equated it to 0. I mean the first derivative and equated it to 0, sorry. And that gave us an answer, two answers, x equals 1 and x equals 0. So these are the critical points of our graph. And then to find our inflection points, then we made the second derivative and we equated that to 0, and this gave us no solution. So this means that there are no points of inflection on our graph, and here's the graph as you can see it here. Thank you very much.